creator and supplier of more than 50 modifications of cold rolling tube mills, with tube diameter from 6 to 450 millimeters, made of various steel grades and alloys on the base of titanium, copper, and aluminum. We are presenting you a new development of EasyTM, the Universal Cold Rolling Tube Mill of lever type CRTM 380-8. We assembled and carried out tests of the equipment on our plant bed. The mill we offer is a further modification of EasyTM developments in creating cold rolling tube mills of large and super large sizes. The new CRTM 380 was created on the basis of CRTM 350, which has been successfully operated by the customer since 2010. The new CRTM 380 has a set of engineering improvements and an extended range of billets and finished tubes as well. CRTM 380 is unique in its technical and technological capabilities. For the first time, mills of this typical size are produced with a front-end loading scheme which improves mill capacity and finished tube accuracy and enables the use of mandrels with a small taper. The use of servo drives for feed and turn mechanisms allows excluding transmission shafts and mechanical converters of constant rotation into an interrupted one from the equipment configuration. Individual servo drives are synchronized with the main drive operation and drive the work of front and intermediate chucks, feed mechanism, and rod chuck. This enables a flexible scheme of mill technological operation where feed and turning angle values are established from the control panel and adjusted in each end position of the stand. The accepted 3-high rolling stand scheme, mutually mobile power housing and roll cassette, has high rigidity and can endure massive rolling forces beyond the capacity of any other mill in the world. Rolling with 3 rolls minimizes metal sticking on a tool, which is especially important for rolling of stainless steel, improves the quality of finished tubes, and enhances the durability of dies and mandrel. Cross-section connector implemented in the cassette case design, locked by means of wedge connections, allows simplifying and reducing time for rolls and tool changing. The lever drive system enables getting periodic forced rolling die diameter along stand stroke. This die diameter is the closest to the designed rolling diameter, which makes it possible to perform rolling with minimal axial forces. The designed arrangement of stand unit and drive mechanism eliminates getting the high-efficiency mineral cooling lubricant of the deformation area on the foundation and eliminates mixing with the lubricant used in the drive mechanism. The scope of supply of CRTM 380 includes a range of accessories and special stands to assist in roll changing and equipment adjustment. Now CRTM 380 is being manufactured, tested, and shipped to the customer, Schultz Group of Companies, Germany, for installation at one of its works in the USA. Later on, you'll see the process of the first tube rolling in the CRTM 350-8 produced by EasyTM for TISCO, People's Republic of China. A batch of billets intended for rolling is put on the rack of the loading table. A billet is fed onto the conveyor rollers from the loading rack with the help of a doser and an ejector. Then the billet is moved by a pusher along the rolling axis in guides behind the billet chuck. After that, the pusher returns to its initial position. The billet is rapidly moved by a billet chuck to the working area of the stand. The billet is fed to the deformation area by its front end. Feed, tube, and rod turn are being performed by the cassette when passing end positions. They can be regulated in a wide spectrum and be adjusted for various values in front and back positions. The rolling process is performed by means of 3 dies in grooves of variable profile on a conic or curvilinear mandrel when cassette and power housing are moving reciprocally. When the rolled tube comes out from the front chuck cams, the punch rollers are switched on. They move the tube to the rack of the finished tube receiving table. Then the roller table descends, shifting the tube to the sloping skid on which the tube rolls over, away from the rolling axis. As the finished tubes are gathered on the sloping skid table, the workshop crane collects them from the table and transports them to the place of storage. New generation mills for small and medium sizes of tubes is another direction in which EasyTM is working now. Our plant is fulfilling the order for the Indian company NFC on engineering and manufacturing CRTM 65-6, intended for cold rolling of tubes made of various steel grades and alloys, with an initial strength limit of up to 1,000 megapascals. The mill operates with front-end loading of billets without stopping to reload. The die is full ring type. The mill has a mobile power stand with working rolls, a drive mechanism with a system of rotating counterbalances to stabilize torque and inertial forces, a loading table, feeding area, and finished tube receiving table. The system of individual servo drives is used for feed and turn mechanisms. This enables a wide spectrum of adjustments. The stand design allows matching optical rolling radius of a die. It makes it possible to minimize axis rolling forces, which in turn has a favorable influence on the quality of manufactured tubes, rolling process stability, decreases wear on main drive pinions and racks, makes it possible to use dies many times with reconditioning along the outer diameter and groove regrinding.